Hi, guys. A couple of things that I want to make sure that we're all aware of when it comes to set notation. This symbol represents the empty set, which is literally the set which contains no elements. It is the set of nothing. So this and this mean exactly the same thing. What if we had a set containing the empty set? This is not the same thing as this, because this is a set that doesn't contain anything at all. And this is the set that contains a set, specifically the set of the empty set. So this is a set that contains the empty set. This is the actual empty set. They are not considered the same thing. These two are the same thing. When they mention a bag notation, they're talking about a way to kind of help people understand what a set that contains sets is. So if I had a set that contains, say, the set of the numbers 1 and 2, and the set of numbers 3 and 4, and the set of numbers 5, 6, and 7, this would be another set that contains sets. The elements of this set are the set of numbers 1 and 2, the set of numbers 3 and 4, and the set of numbers 5, 6, and 7. So this set, let's call this, I don't know, S. Set S contains 3 elements, this set, and this set, and this set. The notation that indicates the number of elements in a set is to take the name of the set. Now, the name of a set is always a capital letter. The notation to indicate the number of elements in a set is to take a lowercase n, and then in parentheses after that put the name of the set, which is going to be a capital letter. So you'll have a lowercase n, and then in parentheses a capital letter. This means the number of elements in set S. And in this case, that's equal to 3. Does that make sense? This is really important to understand. This notation means the number of elements in this set. The universal set is indicated as a capital U. And it means the set of all possible elements that are under consideration. It will change from one problem to the next. A Venn diagram is always going to be a box, and this box represents the universe for that particular problem. And then they indicate sets as a circle. So we might have set A within this particular universe that contains the numbers 1, 2, and 3. Perhaps we have a set B which also contains the number 2. So I wouldn't write the 2 twice. I would put the 2 in the intersection between the 2 circles. So maybe B contains the numbers 2, 4, and 6. So set A is the set of numbers 1, 2, and 3. Set B would be the numbers 2, 4, and 6. The universe for this particular problem has the numbers 1, 2, 3, 4, and 6. You'll notice that the number of elements in A is 3. The number of elements in B is 3. And the number of elements in U is only 5 because the 2 is in both A and B. So when we count the number of elements in A and the number of elements in B, the 2 gets counted both times. We have a couple of important symbols that indicate operations between sets. When we put what looks like a U, but it doesn't have this extra little loop to indicate that it's actually literally a capital U. This U means the union. And in this case, because we haven't listed any elements that are outside of either A or B, the union of A and B, in this case, A union B, is going to turn out to be the same as our universe. It would be the numbers 1, 2, 3, 4, and 6. A union is going to be indicated by the word or, because in order to be in the union of A and B, it has to be in either A or B, or it can be both. Now the both part is called the intersection, and they flip this symbol upside down to indicate the intersection. Just like the intersection of 2 streets is where they cross. The intersection of 2 streets is that part which is literally in both streets. So the intersection of A and B would be the set of numbers that are in both A and B. So the intersection of A and B would be just the number 2. And to talk about the intersection, we have to use the word and. It has to be in both A and B. There is no or involved here. What if we had a problem where the universe consisted of all of the digits 1 through 9? We've got a set A that has the numbers 1, 2, 3, 7, and 8. We have B has numbers 2, 5, 6, 8, and 9. We could draw a Venn diagram for this. There is an intersection between A and B, so we got to make sure that the circles for those overlap. So we can call this one A, this one B. Here's the universe. So the number 1 is in A, but not B. The number 2 is in the intersection of A and B. 3 is in A only. 4 is not in either A or B, so we can draw that out here somewhere. 5 is in B. 6 is only in B. 7 is only in A. 8 is in the intersection, and 9 is only in B. So, of the numbers 1 through 9, 4 is not in either. 2 and 8 would be the intersection. So we could write that the intersection of A and B is the set of numbers containing 2 and 8. The union of A and B would have, let's see, 1, 3, 7, 2 and 8, 5, 6, and 9. There is a notation for something not being in a set, and that is to put a little accent mark after the letter. So not A would be the set of all of these numbers in the universe that are not in A. That would be 5, 6, 9, and 4. So 5, 6, 9, and 4 are in not A. The number of elements in A is 5. The number of elements in B is 5. The number of elements in the universe is 9. The number of elements in the intersection of A and B, 2 and 8, is 2. These are also called cardinal numbers. The cardinal number means the cardinal number differentiates between the number that's in the set, the actual element in the set, and the number of elements in the set. The elements in A intersect B are 2 and 8. The cardinal number for A intersect B is 2 because there are 2 elements in A intersect B, even though the number 2 is actually one of the elements. So the cardinal element is 2 because there are 2 elements. Does that make sense? See the difference between them? There is a symbol which means is an element of, and it looks kind of like a funky E. And then there is the E element with a line through it. This line always negates it. Just like this little accent here means not in A, this means is not an element of. So I could write the statement 2 is an element of set A. 5 is not an element of A. So that's a few more things that you might find really helpful in talking about sets. Hope you enjoyed this one, and we'll see you later.